Hi, we'll be solving problem 8 of exam 1. I couldn't solve the problem during the exam because I didn't devote enough time to practicing these types of problems. And so when I reached this problem, I froze and was unable to recall what I had studied and practiced. Now that I've gone back and done these types of problems though, I'm confident that I'm able to solve the problem. So let's get started. So the question says a projectile is fired from the top of a cliff of height h above a valley. Its initial velocity is v equals 60 meters per second at an angle theta above the horizontal. The time of flight, that is how long projectile remains in the air, of the projectile is t equals 12 seconds. The range, horizontal displacement, r equals 400 meters. So what I'm going to do is I'm just going to write the information that we have up top here. (60 meters per second) is the initial velocity. T equals 12 seconds, that's time. And then r, which is our delta x, equals 400 meters. Okay, so problem A asks, what is the projection angle, theta, in degrees? So what I'm going to do is I'm going to take our delta x, or r, 400 meters, and I'm going to set it equal to the time multiplied by the velocity times cosine, because it's x is going in the horizontal direction, so it's cosine. We're going to divide 400 by 12, and that's going to give us 33.33 equals 60 cosine theta. We're going to divide by 60. That'll be 0.5556 equals cosine theta. Then theta equals 56.25 degrees. Okay, that's how you solve the projection angle. We took the delta x, set equal to the time, multiplied by the velocity and cosine, and that's it. So we're going to go on to problem B. Problem B asks, what is the height h of the cliff? So first, we're going to have to find our VIY. And so to do that, we are going to do sine 56.25. Sorry for the mess. It's kind of hard holding a phone and doing problems. Major props to the TAs. Sine 56.25, and we're going to set it equal to x over 60. So x over is what we're trying to find, the VIY, over the initial velocity, and set it equal to sine the degrees of the projection angle. And so VIY, which is x in this problem, is going to equal 49.89 meters per second. And now that we have our VIY, we can go on to find the distance, or the height. So D equals 49.89 meters per second times total time, which is 12, plus 1/2 times the acceleration, which is negative 9.8 meters per second squared, times time squared. Okay, and our height, our D, once you solve it, is going to be 106.92 meters. Okay. So the height that the projectile is fired from is 106.92 meters. C asks, what is projectile speed just as it reaches the ground before hitting the ground? So we have our x from here, our VIX, which is 33.33 meters per second. And in order to find the projectile speed just before it reaches the ground, we also have to find the velocity. Sorry. So it's going to be v squared equals 49.89 squared plus 2. The 49.89, remember, is our VIY, plus 2 times the acceleration, which is negative 9.8, times the height of the cliff, 106.92 meters. Okay, and that's going to get us our VY, which is 67.71. Okay. Then we are going to take the square root of x and y squared. And that is going to equal 75.47 meters per second. So what I did was I plugged in 33.33 into x and 67.71 into the y. Then solved it and I got 75.47 meters per second for the projectile speed just before hitting the ground. Alright, and that is how you solve problem 8. I'm really happy that I was able to go back and do this. Thanks.